Alright, this is section 2.1. And so in section 2.1 we deal with functions. So what I did here was I gave you a kind of a bizarre function initially with a whole bunch of stuff in it. So I wanted to show you an idea that makes all this easier, which is f of blank. This is my idea. You won't find it in a textbook. So instead of x, I write a blank set of parentheses wherever I see an x. So instead of f of x, I write f of blank. Instead of 7x cubed, I write 7 blank cubed. Instead of 5 square root of x, I write 5 square root of blank. Absolute value of x is absolute value of blank. And 8x is 8 blank. Now what happens is whenever they give you an input, you put it in the exact same spots wherever there's a blank parentheses. Now, when we're dealing with domain, which will be 53 through 72, those problems, we only have to worry about two things: if there's a fraction or if there's an even root. If there's a fraction, we're worrying about division by 0. So we set the denominator equal to 0 and solve. And the domain will be everything else. So basically whatever answer you get here, you're going to throw it out. And the domain is whatever's left. Now for even roots, it's the opposite. With an even root, we're worried about the even root with the negative underneath it. So we want it to be 0 or positive, so it won't be negative. So we set what's under the expression, under the root, greater than or equal to 0, and when we solve it, we keep that answer. So notice for even roots, whatever answer we get, we keep it. That's our domain. With a fraction, whatever answer we get, we throw it out. That is not your domain, it's everything else. Alright, with piecewise functions, we're going to look at the input value, and based on what our input is, we'll see which line we're going to use. They have several lines in a piecewise function, sometimes 2 or 3. You choose that line, you plug in the input value, and you get your answer. The final one is called the difference quotient, and on that one, this is going to be a question that's not only on test 1, but it's also going to be on your final. So you need to know this question. The question is basically part 3, this guy right here. Up here is just getting everything ready. It's sort of like when you're baking a cake, you mix all the dry ingredients together, you mix all the wet ingredients together, and then you put them together to make your cake. So here we first find f of blank. It's very important you do that. Then find f of a, meaning you put a in for every blank parentheses. And then f of a plus h, you put a plus h in for each parentheses. You find out what each one is, you simplify it, and then you put it in here. Put this one in here and that one in there. Make sure you put brackets around them. And when you subtract them, some things will go away. And finally, you'll be able to divide by h, and you get your answer. Alright, so in 2.1, they first give you f of x equals x cubed plus 1. So f of blank equals blank cubed plus 1. So what that means is if I put a negative 1 there, I put it there as well. So f of negative 1 is negative 1 cubed plus 1, and you get 0. F of 2, you put a 2 in there, and you get 2 cubed plus 1, and you simplify. And then this final one is what's f of 2 subtract f of negative 1? Well, we already know what f of negative 1 is. It's 0. And we know what f of 2 is. It's 9. So this is just 9 minus 0. Alright, so then they ask you what is the input values called, the domain, and what are the output values? That's range. And then they ask you if 5 is in the domain of each of these functions. So you throw 5 into each function, see if you get a legitimate answer. This one's going to give you 10, which is a fine answer. This one's 0, that's okay, it's 2. This one gives you square root of negative 5, that's not okay. So 5 is not in the domain of this function called h. Part B says plug 5 into each of the functions that has 5 in its domain, meaning f and g, and see what answer you get. And there you go. Then question 10. Question 10 says create a function where you add 2 and multiply by 5. So f of x equals x plus 2. There's your add 2. And then you multiply the whole thing by 5. Then they ask you, with question 14, they give you the function, and they ask you to come up with the words. Well, what are you going to do first to the x? You're going to square it. Then you're going to subtract 2. And then the whole thing is going to be multiplied by 4. So you work your way from inside out slowly. Alright, what about 22? They give you this function here, 4x minus x cubed. So 4 blank minus blank cubed. So you plug in a minus 2 there. 4, negative 2, subtract negative 2 cubed. Plug a 0 in there. 4 times 0, subtract 0 cubed. Plug a 2 in there. A 1, and then a 1/2. And you get your answers. Same thing here, but this is just x squared plus 2x, so blank squared plus 2 blank. So 0 squared plus 2 times 0. 3 squared plus 2 times 3. Negative 3 squared plus 2 times negative 3. Make sure when you put things into your function you use parentheses, because negative 3 in parentheses squared is different than negative 3 without the parentheses squared. With the parentheses, negative 3 squared is 9. Without the parentheses, negative 3 squared is negative 9. Alright, so now they ask you f of a. This is where you're going to want to use this blank idea for sure. So f of a equals a squared plus 2a. F of negative x is f of negative x equals negative x squared plus 2 times negative x. F of 1 over a equals 1 over a squared plus 2 times 1 over a. Alright, this one's 2 absolute value x minus 1, so 2 absolute value blank minus 1. And you plug in all these numbers and do your absolute value like you normally would. The trickier ones are here. 2x plus 1, subtract 1. And then x squared plus 2 goes in there for your blank, and you simplify them. The only one that's a little tricky is this one. If you take the absolute value of x squared plus 1, you're going to get the same answer as just x squared plus 1, because any number when you square it is positive or 0, and when you add 1 to it it's positive, so the absolute value isn't really doing anything there. 34, piecewise function. They throw in these numbers, and based on that you decide which one you're going to choose. We use the top line if our input is 2 or smaller. So negative 3 is smaller, so we use the top line and we just get 5. 0 is smaller than 2, so we get the top line, which is just 5. And 2, if x is 2, that's still the top line, and so we just get 5. The bottom one, notice you plug a 3 in there, now you're using the bottom line, so 2 times 3 minus 3, or 2 times 5 minus 3. This one says if it's smaller than minus 1, you use the top line. Well, this is these first two are the top line. They're smaller than minus 1. So that's minus 4 squared plus 2 times minus 4. That's minus 3 halves squared plus 2 times minus 3 halves. Now minus 1, that's also the top line, because notice we have equality here with minus 1. So it's minus 1 squared plus 2 times minus 1. 0, that's the middle line in between minus 1 and 1, so you f of 0 equals 0. F of 25, you're using the top of the bottom line, and so your answer is just negative 1. And now this one gives you the function, which is f of blank equals blank squared plus 1. So f of x plus 2 equals x plus 2 squared plus 1. And f of x plus f of 2, well, f of x is just x squared plus 1, we know that. F of 2 is just 2 squared plus 1. And when you simplify all that down, you get this. G of t, well, remember that's g of blank equals 1 subtract blank squared. Okay, so you plug in a minus 2 there, and you get 1 minus 2 squared. Here you plug a 5 in there, you get 5 equals 1 minus 5 squared. And finally 5 subtract negative 2 is just minus 24 minus negative 3. Okay, and this one is h of blank equals blank squared plus 5. So you plug in a 6 and you get 6 squared plus 5. Plug in a minus 3 and you get minus 3 squared plus 5. Then finally they ask you to find the net change between 6 and minus 3. So that's just h of 6 minus h of negative 3, which is 41 minus 14. Now here's that hard question I was telling you about that's going to be on test 1 and on the final. So you give you a function and you write f of blank. Then you find f of a. You plug a in there and simplify it. Then you plug in an a plus h in each spot, and that you simplify. Now you got to know what a plus h squared is. It's a plus h times a plus h, which gives you these three terms. And the minus 4 times each one gives you those last two terms. So here's your f of a plus h, here's your f of a. And so now this guy is this rectangle here, goes there. And this guy is your second rectangle, goes there. Now when you drop your brackets, this negative distributes to each of these guys, makes that subtract a squared and add 4a. Don't forget the second guy gets hit with that negative sign. Now you can cancel some terms that don't have an h in them typically. A squared minus 4a plus 4a. So when you're done, you should have only terms that have an h in them. That's one way of checking your work. Okay, so an h cancels with each one of these, leaving you with a 2a, a h, and a minus 4. It doesn't just cancel with one, it's dividing into each term. Alright, and so the same thing's going to happen here. F of blank equals 1 over blank plus 1. So f of a is 1 over a plus 1. F of a plus h is 1 over a plus h plus 1. The only problem with this one is it's just it's a fraction within a fraction. So you get this first fraction minus this second fraction. Now if you're going to combine them, you got to get a common denominator. So the first one, you multiply it by the second one's denominator. The second one, you multiply it by the first one's denominator. Then when you multiply 1 times a plus 1, you get a plus 1. You multiply 1 times a plus h plus 1, you get a plus h plus 1. Now when you combine these two, you're going to distribute that negative sign and hit each one of these. So that's minus a, minus h, minus 1. And now when you simplify those guys, you just get your 1 and minus 1, your a and minus a cancel, and you just get minus h on the top. Remember on the bottom you got h or h over 1. When you have a complex fraction, you can take the bottom, flip it, and multiply it. So instead of h over 1, you're multiplying by 1 over h. What that does is it allows you to cancel your h's, and you just get minus 1 on the top, and you have that denominator on the bottom. There's your answer. 52, same idea, it's just a different function. That's f of blank equals blank cubed, so f of a equals a cubed. F of a plus h equals a plus h cubed. Multiplying that out takes a bit of work, but you get this guy here. I actually could have simplified that some more by combining terms, but whatever. So now you write this guy minus that guy. And when you drop your brackets, that becomes a negative a cubed, and they cancel. And then you've got this guy all over h, which the h cancels with each one, leaving you with this. And now, I should have simplified earlier, but this is 1a squared plus 2a squared, which is 3a squared. This is 2ah plus 1ah, which is 3ah, and you get your a squared as well. Okay, now 53, they're asking you to find the domain. The domain here, notice there's no fractions, there's no even roots, so your domain is everything. Same thing with the range. Same thing with this one. This is a line, so your domain is typically everything, but notice they restrict it from minus 2 to 6, so you've got to go with that domain. Now how do you know what the range is? Well, you plug in these endpoints in here and you'll get what your range is. 3 times minus 2 is minus 6. 6 times 3 is 18, so minus 6 to 18. On this one, your domain is everything but where you're dividing by 0. So you set the denominator equal to 0 and you get negative 3. And like I said, you throw out the negative 3.